We're back. More lessons about the brain. I think I'm just going to get into it because we have a lot to do. No shot. Oh, that's so cool. The Stream Elements literally posts the emote. Okay. Whoa, chill. Someone outside is going crazy. All right, little brains wire themselves to their world. Many animals emerge from the egg or womb with brains that are more fully wired to control their bodies, but little human brains are born under construction. Why did we evolve this way? To be born with our brain wiring only partially complete. No one knows for sure, though plenty of scientists have been happy to speculate. What we can learn is where those wiring instructions come from after birth and what advantages this arrangement affords us. We cannot attribute causes to genes alone or to the environment alone, blah, 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 nature and nurture, blah, 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 usual stuff. To a remarkable extent, a baby's genes are guided and regulated by the surrounding environment. Guided in the sense that their expression is affected by the environment. So this is epigenetics. The brain areas that are most centrally involved in vision, for example, develop normally after birth only if a baby's retinas are regularly exposed to light. So this is really important, actually. I'm going to gank this real quick. Is this the one where it gets rid of like half the letters? I have to type these out, unfortunately. To a remarkable extent, a baby's genes... Wait, what am I doing? What if I just did this? How crazy would this be? Get Gemini open, and I say, to a remarkable extent, a baby's genes are guided and regulated by the surrounding environment. The brain areas that are most centrally involved in vision, for example, develop normally after birth only if a baby's retinas are regularly exposed to light. Easy. Okay. We're losing a little bit of punctuation, but I think that's fine. Let's ship it. To a large extent, surrounding environment, the brain areas that are most essentially, for example, develop normally. Okay. An infant's brain also learns to locate sounds in the world based on the specific shape of the baby's ear. To make matters even stranger, a baby's body requires some additional genes that sneak in from the outside world. These tiny visitors travel inside of bacteria and other critters and affect the brain in ways that scientists are only beginning to understand. A baby's wiring instructions come not only from the physical environment, but also from the social environment, from caregivers and people like you and me. When you cradle a newborn girl in your arms, you present your face to her at just the right distance to teach her brain to process and recognize faces. When you expose her to boxes and buildings, you're training her visual system to see edges and corners. Many other social things we do with a baby, like cuddling and talking and making eye contact in key moments, sculpt her brain in necessary and irrevocable ways. Unfortunately, I have to write all this stuff down. I should just, if I know that I'm going to have to write it, I should just write it while typing it. I'm sorry. Write it while saying it. But also from the social environment, from caregivers and people like you and me. When you cradle a newborn girl in your arms, you present your face to her at just the right distance to teach her brain to process and recognize faces. You expose her to boxes and buildings. Your training. Her visual system to see edges and corners. Many other social things we do with a baby, like cuddling and talking and making eye contact. And key moments. Sculpt her brain in necessary and irrevocable ways. That's why I always find it so, like on paper, so nerve-wracking to to interact with like a really young baby. It's like everything that you do is affecting the trajectory of their entire life. When you expose her, okay. Genes play a key role in building a baby's brain wiring, and they also open the door for us to wire her newborn brain in the context of her culture. As information travels from the world into the newborn brain, some neurons fire together more frequently than others, causing gradual okay. This is the type of thing that we want to talk about in the context of culture. Genes play a key role in building a baby's brain wiring, and they also open the door for us to wire. Okay. This is all really important stuff. Genes play a key role in building a baby's brain wiring, and they also open the door for us to wire her newborn brain in the context of her culture. As information travels from the world into the newborn brain, some neurons fire together more frequently than others, causing gradual brain changes that we've called plasticity. These changes nudge the infant's brain toward higher complexity via two processes we'll call tuning and pruning. Oh man, it's a lot to type. Should I just do it all using Gemini here? How does ChatGPT add punctuation here? Yo, Darmadon, what's good? Oh, what does this do? Drag to moderate. Whoa, that's a lot. Okay. Yikes. Stanites, how are we? We're doing good. We've got some new emotes going on. Okay, so the emote does show up, right? Now, do all the emotes show up? Yo, Onion Helmet, what's good? Are these going to show up on the screen? No? Does it just not know how to do it? Got 4 songs so far. Started a new album. Oh my gosh, that's awesome. What was the impetus? Oh, how do we get this up on the screen? We got to get the Shermas on the screen. And what's the style you're going with, or like what trajectory are you going with? I guess you did mention rock, right? Thought up a process and started executing it. Very cool. Thank you for bringing back Podfriend. We trust in your revolutionary ideal ways, Chairman. Thank you. Thank you, thank you. It was only right that we reinstate order in the world. Okay, let's go. Dictate. Tuning means strengthening the connections between neurons, particularly connections that are used frequently or are important for budgeting the resources of your body, water, salt, glucose, and so on. I'm gonna call it there. What did I just miss? Isabella Michael, thank you for the follow. Welcome to the stream. Welcome to the community. Oh, look at this. This one's giving us punctuation. Very cool. All right, we got to continue here. I'm sampling Indian percussion and then putting it in a microtonal sampler thing and playing those on my keyboard. That is awesome. Putting flute samples in the sampler. Hell yeah. Very nice. Dom will drop the hottest album since Elvis. Wow. Yeah, sampling's pretty neat. Is this something you're playing around with, or did you used to sample as well? Okay, we gotta get all this. If we think again of neurons as little trees, tuning means that the branch-like dendrites become bushier. It also means that the trunk-like axon develops a thicker coating of myelin, a fatty bark that's like the insulation around electrical wires, which makes signals travel faster. Well-tuned connections are more efficient at carrying and processing information than poorly tuned ones, and are therefore more likely to be reused in the future. This means the brain is more likely to recreate certain neural patterns that include those well-tuned connections. As neuroscientists like to say, neurons that fire together wire together. Does it work? Oh my gosh. Oh, sorry. Look at all that. So I'm just doing this because when I copy from the actual book, it doesn't include all the letters. So I have to use this to transcribe it. Yes, I've done albums where I don't play a note. Nice, all samples. That's really cool. Very cool. Yeah, one of these days I'll get back to music, and I do need to start messing around with sampling. All right. Meanwhile, less used connections weaken and die off. This is the process of pruning, the neural equivalent of if you don't use it, you lose it. Pruning is critical in a developing brain because little humans are born with many more connections than they will ultimately use. A human embryo creates twice as many neurons as an adult brain needs, and infant neurons are quite a bit bushier than neurons in an adult brain. Unused connections are helpful at the outset. They enable a brain to tailor itself to diverse environments, but over the longer term, unused connections are a burden, metabolically speaking. They don't contribute anything worthwhile, so it's a waste of energy for the brain to maintain them. The good news is that pruning those extra connections makes room for more learning. That is, for more useful connections to be tuned. Now, do we remember who is a big player in pruning? Who's going around eating synapses that are designated too weak to be necessary to stay around? Because microglias, that's what I was gonna say. Because I don't remember the name. That's exactly right. So this pruning process is one where like literally the synapses that aren't used enough. I don't know if they get sprayed with something, like a molecule that these microglias go after, like that. Literally, imagine the microglias are like trying to smell these things, or if it's just a product of their disuse that it ends up being like it ends up having a chemical reaction such that microglias want to eat them up. But yeah, this is how we like literally like learn our basic fundamental foundational understanding of the world. It's through these early Early years of pruning. Okay. Okay. Skank that whole thing. I'm gonna have to obviously rewrite this stuff in a way that I think is appropriate for the document. Tuning and pruning happen continuously and okay, I gotta get this one in there too. This is all just too important stuff. Tuning and pruning happen continuously and often simultaneously, driven by the physical and social world outside the infant's head and by the growth and activity in the infant's body. Both processes also continue throughout life. Your bushy dendrites keep sprouting new buds, and your brain tunes and prunes them. Buds that aren't tuned disappear within a couple of days. Yikes. Microglias or microglia for the proper name. Nice. We gotta get we need an emote for microglias. I don't know what they look like, but we should just have something that is eating things. Gotta have brain buds. Hell yeah. Did they? Oh, buds, yeah. Yeah. What are brain buds? Brain buds. Okay. Maybe, what are brain buds? I'm hella glutamated right now. Microglia. That's exactly what they say. I'm the inventor, AMA, of brain buds. It's isn't one single standard term. It's used in different contexts. The meaning depends on where you saw it. A brand name? Nope. Early brain outgrowth. A budding brain. So, yeah, I guess budding connections. Whether that's, you know, budding axons or budding synapses. All right, we need to keep that. We need to keep that just so that I can get more quotes. If caregivers do these activities effectively, the baby's brain is free to tune and prune itself to perform healthy body budgeting. Little by little, the caregiver's roles diminish as the infant's brain become... Okay, this is really important as well. All these things I probably should just assume is... okay. Consider how you manage your body budget. When you're hungry, you can open the fridge. When you're tired, you can go to bed. When you're cold, you can put on a coat. When you're agitated, you can take deep breaths to calm your nerves. Babies can't do any of these things by themselves. They can't even burp without help. That's where caregivers come in. They regulate the baby's physical environment and their... Okay. That's where I'm going to start. That's where caregivers come in. They regulate the baby's physical environment and therefore her body budget by feeding her, setting sleep times, and wrapping her in blankets and cuddles. These actions help the baby's brain maintain its body budget so her internal systems operate efficiently and she stays alive and healthy. If caregivers do these activities effectively, the baby's brain is free to tune and prune itself to perform healthy body budgeting. Little by little, the caregiver's role diminishes as the infant's brain becomes more capable of controlling her body, enabling her to fall asleep without being held or to stuff a bit of banana into her mouth without smearing it on her face. It may take years before the little brain can put on a sweater by herself or make her own breakfast, but eventually she'll have primary responsibility for her own body budget. Little brains are also wired by what caregivers don't do. If you don't let a baby fall asleep on her own and instead rock her to sleep every night, her brain might not learn how to fall asleep without help. When an infant is crying for a long time and you don't check in regularly, her brain may learn that the world is unreliable and unsafe while her body budget goes untended. Things change once she's a toddler, however. Her toddler brain has to learn to calm her body after a tantrum and eventually to body budget without a tantrum in the first place. When my daughter was little, I found it helpful to give her space so her brain could learn to soothe her body. In general, toddlers learn to tend their own body budgets better when their caregivers create learning opportunities for them instead of hovering and taking care of their every need. Wow. Did you guys know babies can't drink water? Oh, just like if you're not supposed to, or it's not good for them? Yeah, that is kind of wild. What is the reasoning for that? Is it just not nutritious enough, or can like their body literally not process it? Do they get dehydrated from too much water? Like water poisoning? In general, toddlers learn to tend their own body budgets better when their caregivers create learning opportunities for them instead of hovering and taking care of their every need. Nice. I think it makes them sick or something. That's why they love milk. Is it a mammal thing? I'm not sure. That's a good question. Is it a mammal thing that newborns cannot drink water? Our second example of tuning and pruning concerns how you learn to pay attention. Have you ever been in a crowd not really attending to the conversation sprouting around you, and then someone speaks your name and you immediately orient to it? Scientists call this the cocktail party effect. Your adult brain can effortlessly focus on one thing and ignore others, similar to a spotlight in the darkness. That's because your brain network contains smaller communities of neurons whose main job is to focus on certain details as important and ignore other details as irrelevant. Your brain focuses its spotlight of attention continually and automatically, and often you're unaware that it's happening. And that's obviously what we're talking about this month. We do not need help. We do need help sometimes to focus our spotlight. That's why noise-canceling headphones sell so well. But the newborn brain doesn't have a spotlight. It has more of a lantern, illuminating a wide area in its physical environment. Newborn brains don't know what's important and what's not, so they cannot focus as adults do. They still lack the wiring that narrows their lantern into a spotlight. Again, the missing ingredient comes from caregivers in the social world. They constantly guide the baby's attention to things of interest. A mother picks up a toy dog and looks at it. She looks at her little boy, then back at the dog, guiding the baby's gaze. She turns to her son and says with intent, "What a cute little doggy," in a singing tone. In a sing-song tone? Okay, this is all stuff that I'm putting all this stuff in the notes for specifically the part 1 section on socially embedded development across the lifespan, where we specifically look at how at different parts of your life you're being socialized. And when I say socialized, I don't mean like literally just you're learning social norms, but you're learning semantic norms about what things are important, what things mean. Like this is all happening because of these important early social interaction. Well, it happens throughout your life. That's the whole point across the lifespan. Even today, we're negotiating on the semantics of what is in the world through our social interactions. Oh, to answer the question though, mostly yes, but it's not a mammal. It's not a mammals can't drink water rule so much as a newborn physiology rule. For human infants, giving plain water can be risky because electrolytes get diluted Too much water can lower blood sodium, which can cause serious symptoms, including seizure, water intoxication. All right, I was right about that one. Which I think it's called, is this not called dehydration as well? Tiny stomachs. Water can displace breast milk formula calories, which they need for growth. Okay. And then immature kidneys. Newborns don't handle excess free water as well as older babies and adults. Do our kidneys mess with free water? What is going on? Okay, around 6 to 12 months, small amounts of water may be introduced. Okay. Many mammals naturally feed newborns only milk, which already contains lots of water. The specific "don't give extra water" warning is most emphasized for human infants because caregivers might offer bottles of water over dilute formula. Very cool. Okay. Here we go. This is good. After months of practice sharing attention with caregivers, an infant will learn to elicit shared attention from them. He will look at them as a way of asking whether something is in his niche and what it might mean for his body budget. In this manner, the infant learns to focus attention even more effectively on things that matter. Okay. Oh, I'm doxing my my blueprints. Our third example of tuning and pruning is how your senses develop in the first few months of life. Babies are bathed in all kinds of sounds. Okay, this is really important too. It's just another example of how these things all come together. It's not just information that babies are learning. They're learning like literally how to perceive the world. In the first few months of life, babies are bathed in all kinds of sounds, including the sound of people speaking. Newborns, with their lantern of attention, take in all the sounds around them. When tested in a lab, newborns can distinguish a wide range of language sounds, including those that they don't hear very often. But over time, tuning and pruning will wire the baby's brain based on the vocal sounds he hears more regularly. Sounds that are frequent cause certain neural connections to be tuned, and the baby's brain starts to treat those sounds as part of its niche. Sounds that are rare are treated as noise to be ignored, and eventually related neural connections fall out of use and are pruned away. So scientists think this sort of pruning may be one reason why children have an easier time learning language than adults do. Languages. Different spoken languages use different sets of sounds. For example, Greek and Spanish have a handful of vowel sounds, while Danish has 20 or more, depending on how they're counted. If people interacted with you in multiple languages when you were a baby, then your brain was likely tuned and pruned to hear and distinguish the sounds in those languages. If you heard only one language as a baby, you'd need to relearn the ability to hear and distinguish sounds outside your language, which is hard. This process works similarly for seeing faces. When you're a baby, you learn to recognize the people around you. Your infant brain was tuned and pruned to detect fine differences in their faces so you could tell them apart. But here, there's a catch. People tend to live around others of the same ethnicity, so babies are often not exposed to a wide array of facial features. That means the baby's brain does not tune itself to detect those different features. Scientists think this is one reason why it can be harder for you to remember the faces of people of an ethnicity different from your own, or to tell one face from another. Fortunately, you can quickly retune your brain and restore this ability by looking at lots of diverse faces. It's much easier than retuning to the sound of a foreign language. Okay. Let's get this in there. I should put this. Okay. These examples of hearing language and seeing faces focus on a single sense, but you live in a multisensory world. For example, when you kiss someone, you are enveloped in a unified experience that combines the sight of a face, the sound of breathing, the feel, taste, and scent of luscious lips, and the racing of your heart. Your brain assembles these sensations into a cohesive whole. Scientists call this process sensory integration. Okay. Gotta go back. Sensory integration itself is tuned and pruned as babies grow. A newborn at first can't recognize his mother by her face because he hasn't learned what a face is, and his visual system isn't fully formed. He might know a bit about how his mother sounds, and he can smell her breast milk. If you put a newborn on his mother's belly, he will wriggle up to her breast by following the aroma. Soon he learns to recognize his mother by different combinations of all his senses together. His little brain absorbs each pattern of sight, smell, touch, sound, and taste, plus sensations from inside his body, and learns its meaning. The person who regulates his body budget is here. Sensory integration conjures his first feeling of trust. It's part of the neural foundation for attachment. Okay. So this is like more of a radical telling of this story than I think people usually grasp. Like, I think when people see a baby like looking around, they think that the baby can see them. Like they think that the baby, like even though the baby's like got their eyes on you, they think that like the baby's able to see you as if it was just another person, but they just don't know who you are. When really the baby's learning how to see a face, and the baby's learning how to do all these other things as well. And all this stuff just kind of happens at the same time, and all right, our 3 examples of tuning and pruning demonstrate how the social world profoundly shapes the physical reality of the brain's wiring. Who knew that caregivers were such effective electricians? This arrangement comes with a risk, however. Little brains require a social world in order to develop typically. Okay, this is also really important. Little brains require a social world in order to develop typically. You've already learned that babies need certain physical inputs, such as photons of light bombarding their retinas, or their brains will never develop normal vision. It turns out that they also need social inputs from other humans who guide their attention, speak or sing to them, and cuddle them at key moments. If these needs aren't met, things can go terribly wrong. And this goes into how, this is how you end up with not just like unsocialized babies, but, babies that aren't able to, or when I say babies, I mean like they grow up, humans that are worse off at being able to regulate emotions. I think Jordan Peterson once said, like, if you don't touch the baby literally dies. And he says it really dramatically, and I remember that distinctly. All right, in some orphanages, babies were warehoused in rows of cribs. Okay, this is during a communist type of issue where they were trying to force a bunch of population expansion, but then there weren't enough caregivers for all the children. So babies were warehoused in, so I guess trigger warning. This is kind of dark stuff, but in some orphanages, babies were warehoused in rows of cribs with little stimulation or social interaction. Nurses or caregivers would come in and feed them, change them, and put them back in the cribs. That was about it. Nobody cuddled these babies. No one played with them. No one conversed with them or sang to them or shared attention with them. They were ignored. As a consequence of this social neglect, the Romanian orphans grew up intellectually impaired. They had problems learning language. They had difficulty concentrating and resisting distraction, probably because nobody had shared attention with them, so their brains never developed the wiring for an effective spotlight. They also had trouble controlling themselves. Alongside the children's mental and behavioral issues, their bodies were stunted, most likely because they grew up without caregivers to keep their body budgets solvent. This meant their brains never learned to budget effectively. A little brain wires itself to its environment, and when that environment is missing key elements for healthy body budgeting, critical brain wiring can be pruned away. So the other thing is that Jordan Peterson's mentioned a bunch of times is like rough and tumble play. Like it's really important for young children to play physically. You know, to like it's good as a you know, if you're like a parent, I guess. It's good to like wrestle with the kids, or at least, you know, give them some type of force so that they learn what they can literally handle, what, you know, their body can take. So when I say learn, I don't mean like they cognizantly learn things. I'm saying like their body is learning all the time, as it's literally learning from just sensory experience. So it's a way of helping the regulation process and learning process, so that the baby can grow up to, or the child can grow up to someone that can feel more comfortable and confident. These after effects are consistent with what scientists know about other babies raised in severely socially impoverished conditions. Their brains develop smaller than average. Key brain regions are smaller too, and important areas of the cerebral cortex have fewer connections. If such children are moved to traditional foster homes in the first few years of life, some of these effects are reversible. Similar risks can arise for any kids reared in institutions without attentive, consistent caregivers, whether these institutions are orphanages, refugee camps, or immigrant detention centers. When children are persistently neglected, in all likelihood, they'll suffer ill effects eventually. The impact might not be immediate and dramatic, as in the Romanian orphanages, but can be gradual and subtle as important wiring goes unused and is steadily pruned away. The fallout may build up over time like a slow drip from a water pipe that eventually bores a hole through your floorboards. For example, a neglected little brain in a socially impoverished environment may wire itself to manage its own body budget alone, without the social support from caregivers and the wiring instructions they provide through their actions. This non-typical wiring imposes a pernicious burden on the body budget that accumulates over years, raising the odds of serious health problems later, such as heart disease, diabetes, and mood disorders like depression, all of which have metabolic underpinnings. Crazy stuff. Okay, to be clear, I'm not saying that we have to keep our little darlings free of stress or their brains and bodies will break. I'm saying that persistent neglect over a long time with no relief is almost always harmful to a little brain. You must also meet their social needs with eye contact and language and touch. If these needs go okay, this is something I should write down. You must also meet their social needs with eye contact and language and touch. If these needs go unmet, the seeds of illness may be planted very, very early. Oh, we lost it. Okay, inadequate nutrition. We see similar consequences when little brains develop in poverty. Research shows that early and long exposure to poverty is bad for the developing brain. Inadequate nutrition, interrupted sleep due to street noise, poor temperature regulation due to lack of heat or ventilation, and other circumstances of poverty may alter the development of the front of the cerebral cortex, namely the prefrontal cortex. This brain area is involved in a range of critical functions, including attention, language, and body budgeting. Scientists are still studying the ways that poverty affects brain development, but we do know that it's linked to poorer performance in school and fewer years of education. Sad stuff. All right, given the powerful impact of neglect and poverty on a little brain, it's tempting to ask how evolution got our species into this precarious situation in the first place. It's risky for a baby's brain wiring to depend so critically on social and physical input in order to develop. Typically, we humans must gain some advantage to offset the risks of developing this way. So what is it? We can't know for sure, but here is my guess based on evidence from evolutionary biology and anthropology. This arrangement helps our cultural and social knowledge flow efficiently from generation to generation. Each little brain becomes optimized for its particular environment, the one it developed in. Caregivers, okay. Let me start at This arrangement helps our cultural and social knowledge flow efficiently from generation to generation. Each little brain becomes optimized for its particular environment, the one it developed in. Caregivers curate a baby's physical and social niche, and the baby's brain learns that niche. When the baby grows up, he perpetuates that niche by passing his culture to the next generation through his words and actions, wiring their brains in turn. This process, called cultural inheritance, is efficient and frugal because evolution doesn't have to encode all our wiring instructions in genes. It offloads much of the job to the world around us, including the other humans in that world. We unknowingly wire the knowledge of our culture into our offspring after birth, for better or worse. Bum, bum, bum. Okay, I think we did it. We got past. But now we got the one that we've got the dead horse here that we're going to beat again, because this is such an important topic. Your brain predicts almost everything you do. Scientists used to believe that the brain's visual system operated sort of like a camera, detecting the visual information out there in the world and constructing a photograph-like image in the mind. Today we know better. Your view of the world is no photograph. It's a construction of your brain that is so fluid and so convincing that it appears to be accurate. But sometimes it's not. So I think there's actually an example here that's very similar to the example you gave, ShermaDonk, of the looking in the mirror. All right, where am I putting this? Predictive processing here? Maybe. To understand why it can be perfectly normal to see a grown guerrilla fighter with a rifle when you're looking at a... Oh, okay. She already did give the example. A few years ago, I received an email from a man who served in the Rhodesian Army in southern Africa in the 1970s, before the end of apartheid. He'd been drafted against his will, handed a uniform and a rifle, and ordered to hunt down guerrilla fighters. To make matters worse, before the draft, he'd been an advocate for the same guerrillas that he was now required to treat as the enemy. He was deep in the forest one morning, conducting practice exercises with his small squad of soldiers, when he detected movement ahead of him. With a pounding heart, he saw a long line of guerrilla fighters dressed in camouflage and carrying machine guns. Instinctively, he raised his rifle, flipped off the safety catch, squinted down the barrel, and aimed at the leader, who was carrying an AK-47 assault rifle. Suddenly, he felt a hand on his shoulder. "Don't shoot," whispered his buddy behind him. "It's just a boy." He lowered his rifle, looked again at the scene, and was astonished by what he now saw. A boy, perhaps 10 years old, leading a long line of cows. And the dreaded AK-47? It was a simple herding stick. For years afterwards, this man struggled to understand the unsettling episode. How had he managed to missee what was right in front of his eyes and nearly kill a child? What was wrong with his brain? As it turns out, nothing was wrong with his brain. It was working exactly as it should have. To understand why it can be perfectly normal to see a grown guerrilla fighter with a rifle when you're looking at a 10-year-old boy with a stick, let's consider the situation from the brain's point of view. From the moment you're born to the moment you draw your last breath, your brain is stuck in a dark, silent box called your skull. Day in and day out, it continually receives sense data from the outside world via your eyes, ears, nose, and other sensory organs. This data does not arrive in the form of the meaningful sights, smells, sounds, and other sensations that most of us experience. It's just a barrage of light waves, chemicals, and changes in air pressure with no inherent significance. Faced with these ambiguous scraps of sense data, your brain must somehow figure out what to do next. Remember, your brain's most important job is to control your body so you stay alive and well. Your brain must somehow make meaning from the onslaught of sense data it's receiving, so you don't fall down a staircase or become lunch for some wild beast. How does your brain decipher the sense data so it knows how to proceed? If it used only the ambiguous information that is immediately present, then you'd be swimming in a sea of uncertainty, flailing around until you figured out the best response. Luckily, your brain has an additional source of information at its disposal: memory. Your brain can draw on your lifetime of past experiences, things that have happened to you personally, and things that you've learned about from friends, teachers, books, videos, and other sources. In the blink of an eye, your brain reconstructs bits and pieces of past experience as your neurons pass electrochemical information back and forth in an ever-shifting complex network. Your brain assembles these bits into memories to infer the meaning of the sense data and guess what to do about it. Your past experiences include not only what happened in the world around you, but also what happened inside your body. Was your heart beating quickly? Were you breathing heavily? Your brain asks itself in every moment, figuratively speaking, the last time I encountered a similar situation, when my body was in a similar state, what did I do next? The answer need not be a perfect match for your situation, just something close enough to give your brain an appropriate plan of action that helps you survive and even thrive. So that's just pattern recognition. This explains how the brain plans your body's next action. How does your brain also conjure high-fidelity experiences like guerrilla fighters in the forest out of scraps of raw data from the outside world? How does it create feelings of terror from a thundering heart? Once again, your brain recreates the past with memory by asking itself, the last time I encountered a similar situation, when my body was in a similar state and was preparing this particular action, what did I see next? What did I feel next? The answer becomes your experience. In other words, your brain combines information from outside and inside your head to produce everything you see, hear, smell, taste, and feel. Okay. Your brain is searching through a lifetime of past experiences, issuing thousands of guesses at once, weighing probabilities, trying to answer the question, what are these wavelengths of light most like? And it's all happening faster than you can snap your fingers. Right, so the default mode network is where we're getting a lot of these possibilities. So when we hush that thing up, then that's what we talked about the other day, where there's significantly less top-down constraint from those parts of the brain. Okay. Your brain actively constructs your experience. Every morning you wake up and experience a world around you full of sensations. You might feel the bed sheets against your skin. Maybe you hear sounds that woke you, like an alarm buzzing or birds chirping, or your spouse snoring. Perhaps you smell coffee brewing. These sensations seem to sail right into your head as if your eyes, nose, mouth, ears, and skin were transparent windows on the world, on a already meaningful world. But you don't sense with your sensory organs. You sense with your brain. What you see is some combination of what's out there in the world and what's constructed by your brain. What you hear is also some combination of what's out there and what's in your brain, and likewise for your other senses. In much the same way, your brain also constructs what you feel inside your body. Your aches and jitters and other inner sensations are some combination of what's going on in your brain and what's actually happening within your lungs and heart and gut and muscles and so on. Your brain also adds information from your past experiences to guess what those sensations mean. For instance, when people haven't slept enough and are fatigued or low energy, they may feel hungry because they've been hungry before when their energy was low and may think that a quick snack will boost their energy. In fact, they're just tired from lack of sleep. This constructed experience of hunger may be one reason why people gain unwanted weight. Okay. Have you ever felt your cell phone vibrate in your pocket when it didn't? Have you ever had a song playing in your head that you couldn't get rid of? Neuroscientists like to say that your day-to-day experience is a carefully controlled hallucination, constrained by the world and your body, but ultimately constructed by your brain. It's not the kind of hallucination that sends you to the hospital. It's an everyday kind of hallucination that creates all your experiences and guides all your actions. It's the normal way that your brain gives meaning to your sense data, and you're almost always unaware that it's happening. I realize that this description defies common sense, but wait, there's more. This whole constructive process happens predictively. Scientists are now fairly certain that your brain actually begins to sense the moment-to-moment changes in the world around you before those light waves, chemicals, and other sense data hit your brain. All right, I gotta write this stuff down. This is something I don't say yet. This whole constructive process happens predictively. Scientists are now fairly certain that your brain actually begins to sense the moment-to-moment changes in the world around you before those light waves, chemicals, and other sense data hit your brain. The same is true for moment-to-moment changes in your body. Your brain begins to sense them before the relevant data arrives from your organs, hormones, and various bodily systems. You don't experience your senses this way, but it's how your brain navigates the world and controls your body. But don't take my word for it. Instead, think of the last time you were thirsty and drank a glass of water. Within seconds after draining the last drop, you probably felt less thirsty. This event might seem ordinary, but water actually takes about 20 minutes to reach your bloodstream. Water can't possibly quench your thirst in a few seconds. So what relieved your thirst? Prediction. As your brain plans and executes the actions that allow you to drink and swallow, it simultaneously anticipates the sensory consequences of gulping water, causing you to feel less thirsty long before the water has any direct effect on your blood. All right, I think I can cut starting with, but don't take my word for it. So the thing is, I'm wondering how much of our prediction in this sense is actually afforded to us by the default mode network, these top-down signals that are actually causing simulated motor movements, other sorts of simulations that would also cause downstream effects. So if you were to mute your default mode network in some sense, then chances are you would be less I'm saying chances are, this is my hypothesis, you would be less forward jumping in some sense. You're not going to be able to be predicting too far into the future because you're not leveraging the things that are usually allowing you to jump far into the future. What is going on outside? Okay, what do we want? We want to just drop this somewhere and say Lisa Feldman Barrett 7.5 lessons. Okay. In a very real sense, predictions are just your brain having a conversation with itself. So in the same vein as what I just said, if we were to mute that conversation, or at least the linguistic aspect of it, you stunt its ability to communicate in that sense. Now, granted, they do show what the heightened synchrony. Now, I imagine that heightened synchrony is actually like, even though that you would think that the brain's like more in tune with the future in this sense, like it's going to be I imagine predicting is actually more of it's a manifestation of your brain cutting itself off and you know, like it's a manifestation of prediction error and you know, pointing out what you should be doing next. Whereas if you're in synchrony, then you're kind of you're present. You're very much fine with the current moment, and you're not letting something jump in the way to say, hey, we got to be doing this other thing. We have to be orienting towards the future. So that's where I would intuit the benefits of you know, mindfulness training. All right, a bunch of neurons make their best guess about what will happen in the immediate future based on whatever combination of past and present that your brain is currently conjuring. Those neurons then announce that guess to neurons in other those neurons then announce that guess to neurons in other brain areas Oh, okay. No, no, no. Those neurons then announce that. That guess. Okay, that's what's going on. Those neurons then announce that guess to neurons in other brain areas, changing their firing. That took me a little too long. Uh, that guess is a noun here, or like that is obviously a pointing. Uh, I don't think that counts as that, but yeah. How would you make that less ambiguous? I think maybe you just do a different word than that. Okay, meanwhile, sense data from the world and your body injects itself into the conversation, confirming or not the prediction that you'll experience as your reality. So your brain issues predictions and checks them against the sense data coming from the world and your body. What happens next still astounds me, even as a neuroscientist. If your brain has predicted well, then your neurons are already firing in a pattern that matches the incoming sense data. That means this sense data itself has no further use beyond confirming your brain's predictions. What you see, hear, smell, and taste in the world and feel in your body in that moment are completely constructed in your head. By prediction, your brain has efficiently prepared you to act. That's if it predicted perfectly, but it never predicts perfectly. There's always some prediction error, which is affecting the trajectory of your conscious experience. Okay, brains aren't wired for accuracy, they're wired to keep us alive. Now here's the final nail in the coffin of common sense. All this predicting happens backward from the way we experience it. You and I seem to... Okay, this is actually all really important stuff that I've recently started saying. All this predicting happens backward from the way we experience it. You and I seem to sense first and act second. You see an enemy and then raise your rifle. But in your brain, sensing actually comes second. Your brain is wired to prepare for action first, like moving your index finger onto a trigger and making body budgeting changes to support that motivation, that movement. It's also wired to route these predictions to your sensory systems, which predict the feeling of cold steel on your fingertip and your racing heartbeat. In the case of our soldier friend, his brain heard rustling leaves, moved his hands on the gun, and guided itself to see enemies that weren't present. Yes, your brain is wired to initiate your actions before you're aware of them. That is kind of a big deal. After all, in everyday life, you do many things by choice, right? At least it seems that way. For example, you chose to open this book and you read these words. But the brain is a predicting organ. It launches your next set of actions based on your past experience and current situation, and it does so outside of your awareness. In other words, your actions are under the control of your memory and your environment. Your actions are under the control of your memory and your environment. Does this mean you have no free will? Who's responsible for your actions? Okay. Let's get this in there. Philosophers and other scholars have debated the existence of free will with pretty much since the invention of philosophy. It's not likely that we will settle the debate here. Nonetheless, we can highlight a piece of the puzzle that is often ignored. Think about the last time you acted on autopilot. Maybe you bit your nails. Maybe your brain-to-mouth connection was too well oiled and you muttered something regrettable to a friend. Maybe you looked away from an engaging movie and discovered that you've downed an entire jumbo bag of red Twizzlers. In these moments, your brain employed its predictive powers to launch your actions, and you had no feeling of agency. Could you have exercised more control and changed your behavior in the moment? Maybe, but it would have been difficult. Were you responsible for those actions? More than you might think. The predictions that initiate your actions don't appear out of nowhere. If you hadn't chomped on your nails as a kid, you probably wouldn't bite them now. If you'd never learned the regrettable words you tossed at your friend, you couldn't say them now. If you'd never developed a taste for licorice, you get the idea. Your brain predicts and prepares your actions using your past experiences. If you can magically reach back in time and change your past, your brain would predict differently today, and you might act differently and experience the world differently as a result. So the whole downstream thing that we can logically take from this is if we cater our experience right now, which becomes our memory in the future, then we can effectively direct the trajectory of our future, even though we are always in the moment, not in complete control, especially when we're not paying attention. So there's things you can do now that affects what you do when you're not paying attention in the future. It's impossible to change your past, but right now, with some effort, you can change how your brain will predict in the future. You can invest a little time and energy to learn new ideas. You can curate new experiences. You can try new activities. Everything you learn today seeds your brain to predict differently tomorrow. This is the entire Stan Richardson document. This is it. That's the thesis. Granted, we kind of build up this whole thing in part one, but today is the only day. Now is the only time. To quote Seth MacFarlane. Oh, when did he say that? Or like in what context did he say that? On a song. Nice. Right. That being said, like this type of view does involve you thinking about some future time in a sense. Like it's not to just take in this moment and, you know, do nothing with it. It's to grasp this moment for the sake of your future. So he is a great singer. I do agree. Yeah. Did he do a Christmas album? Am I going crazy? All right. I think that was it. Your brain secretly works with other brains. We gotta. I think I have stuff for this. Brains make more than one kind of brain. Yeah, I definitely have highlights for these, so I gotta figure that out. But we don't have to deal with that today. I think we got to go back to the stuff we started yesterday. We got to learn about these hormones. These chemicals. So to go over what we started yesterday, we started with norepinephrine, which effectively allows us to focus on one thing. It's using our Fortnite level conceptualization. It's a multiplier for attention. Anything that is not salient enough gets canceled out. It's like you multiply it by a fraction, and anything that's salient, you multiply it by some number greater than 0. I'm sorry, greater than 1. Imagine in the future we have brain types like we have blood types. Ooh, I wonder how that would work. I mean, still the closest thing would be something having to do with your DNA, right? It would be something like you have these types of neurons, or your neurons have this type of DNA that actually helps it out in some form, like it's able to build proteins that give you a cognitive boost, or make you more introverted or whatnot. Like we could come to learn that, but I don't know if it's going to be used in the same way where it's like if someone had a brain problem, that you would need someone else with that same brain type. We need tech enhanced meditation already. Oh, that's coming. That's definitely coming. For sure. Yeah, like I wonder if so what's a good analogy for this? Brian Johnson, he's got this like gadget that he puts on his stomach, and it does like a, I don't know what it's using, but it's like stimulating his abs in such a way that he claims it's doing significantly more work than if he were to just do sit-ups. And I wonder if there's a way that you can do something for the brain that builds the same connections that we would build if we were to put in the work of meditation. Like, could you do that? Is there something that would actually be able to affect that type of growth and change? Because that's really what I'd imagine Elon Musk is trying to get to with Neuralink. He's trying to get to a point where he can start building connections that aren't, you know, quote unquote deserved or quote unquote, you know, normally brought about. But I'm sure you're going to run into so many issues with, you know, ramifications that you just don't, that we don't understand yet. Like, we really don't know too much about really sophisticated brain activity when it comes to consciousness. So yeah, like I don't know how much that's in the cards unless we start leveraging AI to really quicken the rate of brain research. Okay, you can look up meditation, ultrasound, neuromodulation. Oh my gosh. Meditation, ultrasound, neuromodulation. So you're using ultrasound to affect the neuromodulation, and it's doing something for your meditation? Is that what's going on here? Is an emerging field of neuroscience research that uses low intensity focused sound waves to stimulate specific areas of the brain to boost or accelerate the effects of meditation. Okay. The core idea is to use technology to help the brain enter a deep state of mindfulness, quieting the monkey mind. That usually why did this come out? That usually requires years of disciplined practice to achieve. So this is really cool. Okay, how does it work? The primary technology involved is transcranial focused ultrasound. Unlike the broad ultrasound used for pregnancy scans, this one uses a highly focused beam of acoustic energy. It can target specific brain structures with millimeter precision, even those deep inside the brain. The effects, it exerts a gentle mechanical pressure on neurons. This doesn't damage the tissue. Instead, it modulates the electrical activity of the neurons. So I was wrong about, like, it's not actually affecting neuromodulators like the neurotransmitters being released. It's neuromodulation a different way. It's modulating activity using a different mechanism here. But that being said, you could excite the parts of the brain that do then release those actual chemical neuromodulators, I'd imagine. All right, by targeting specific brain regions associated with mind wandering and selfing, thinking about me, researchers aim to quiet the inner monologue, allowing a novice meditator to experience the clarity and equanimity of a master meditator. Yes, but is this something that does this affect their learning? Because, you know, I don't want to just get the fish. I want to learn how to fish, right? So if this is only going to give me that experience, then I'm not interested. I'm trying to build this thing so that I can do this at all times of the day. Okay. How much of this actually affects the speed of learning? I noticed that it can be helpful for newcomers because there is a barrier to entry. However, does this actually affect increased learning? Or is it just giving the potential end state if someone were actually to put in the time and meditate, like a teach a man to fish versus give a man a fish. Okay, I'm not sure it helps a lot. I heard they had success triggering equanimity and they want to trigger non-dual experience. This West teacher, they did it on Shinzen Young. He said the equanimity it gave him affected his practice massively. Oh, that's really cool. So, yeah, I mean, I guess it could just give you a feeling that makes you more motivated or changes the way you think about things. I'm just wondering how much change is actually happening at the level of your control, as opposed to just how you feel. This is the most critical question in the field right now. To use your analogy, it is currently designed to be a fish finder, not a free fish. Okay. Research from that lab in Shinzen Young suggests the technology is a scaffold or training wheels rather than a permanent fix. Here is the breakdown of how it affects learning versus just providing a temporary state. The reference point theory, teaching you how to fish. The biggest barrier for new meditators is that they don't actually know what they're looking for. You are told to let go or drop the self, but you have no reference experience for what that feels like. You spend years guessing if you are doing it right. So that's actually true. Like, you could perhaps learn more effectively by just having the goal state more in mind. So by having that memory of what that felt like, you can maybe, you know, when you're meditating, you can try to find something similar or something that gives you the feeling of a pattern recognition. The device inhibits the posterior cingulate cortex for a short window. During that window, the noise of the self drops away. You suddenly experience exactly what the target state feels like. When the machine turns off, you now have a clear target memory. The next time you sit to meditate without the machine, you aren't guessing. You are trying to navigate back to a specific feeling you already have. That you have already tasted. Nice. Neuroplasticity, rewiring the brain to fish better. It isn't just about the subjective feeling. This is a biological component to the learning. Hebbian learning. The rule neurons that fire together, wire together applies here. By artificially forcing the brain into a high equanimity state, the ultrasound strengthens the neural pathways associated with the state. Long-term potentiation. Preliminary research suggests that focused ultrasound can induce long-term potentiation, which is the cellular basis for learning and memory. This means the brain becomes stickier for the state, making it easier to access voluntarily later. So this all checks out. I feel like this is a good argument towards it is teaching a man to fish without actually teaching like in a conventional way. This is the most you could teach. This is the most you could teach without actually telling someone anything. It's not even you're like showing them in some sense. You're actually just it's almost like we don't purposely build the connections in our brain that make us addicted to something, like whether it is addicted to alcohol or whatnot. Like, it's doing that itself. And in this same way, you're building these connections that allow you to, in this case, deliberately get into a state of mind. I reckon this stuff will be huge. Oh, absolutely. Yeah, if this is as effective as they're talking about, I imagine this would be really huge. How do we get our hands on this? In pilot studies at retreats, participants who received the ultrasound did not just feel high for an hour. They reported deeper meditation sessions days after the stimulation, suggesting a lasting afterglow or training effect. The risk, the state versus trait trap. Despite the optimism, your give a man a fish worry is valid. There is a distinction in neuroscience between a state, temporary experience, and a trait, permanent character attribution. If a user relies only on the machine, they experience the state of enlightenment without building the mental muscles required to maintain it as a trait. Right, so yeah, you wouldn't build all the right muscles. Now, I guess this relies on the ability for it to build like a holistic skill. So maybe if you just fire or stimulate the one area of the brain, then that's not effective enough. You want to stimulate multiple areas of the brain that you want to obviously wire together. The crutch effect: if the PCC is inhibited for you, your brain might not learn the inhibitory control mechanisms required to quiet the PCC yourself. This is similar to how wearing a black brace can eventually weaken your back brace can eventually weaken your back muscles because they stop working to support you. Verdict: it's a flight simulator. The most accurate analogy is that meditation ultrasound is like a flight simulator for pilots. It's not the real plane, but it lets you experience flying safely so that when you get in the real cockpit, you learn much faster because you already know how the controls are supposed to feel. It likely does speed up learning, but only if paired with active effort. If used passively, it will likely remain a temporary free fish. Very cool. Must be slow because I heard about it like 7 years ago. Oh, geez. If anyone could have like a menu of states to pick from, I'm sure we're heading there. In the year of our Lord 2026, what's the word here? How validated is this? When is it likely to be offered as therapy more broadly? Because yeah, if you can shut off the default mode network for anyone that's like experiencing significant anxiety, then you've got a crazy thing on your hands. That being said, no one wants to just like effectively sedate themselves. In the context of early 2026, here is the State of the Union on meditation ultrasound. This technology is scientifically validated as promising, but not yet proven for mass adoption. It is not available as a standard therapy at your local clinic, nor can you buy a credible device for home use yet. It remains largely inside university labs and select clinical trial sites. However, it has moved from fringe science to a serious contender in psychiatric treatment. It's got a 6 out of 10 validation score. Oh my gosh. Okay, phase 1. Because it's being fast-tracked for depression and anxiety, we will likely see it offered in specialized psychiatric clinics first. Okay, wow, now to 2028. A doctor might prescribe it for treatment-resistant depression, and the side effect will be a meditative, like, quiet mind. Okay. High-end retreats, 2026 to 2029. The SEMA lab has been testing enhanced retreats where experienced meditators receive stimulation to deepen their practice. This is the first place a non-patient might encounter it. How much meditation allows us to be called an experienced meditator, do you think? Is this like, we're talking 5 years? Are we talking 10 years? Broad therapy, okay, this is way far away. Is the emergence of consumer neural wellness wearables. That's the concern. You may soon see headsets claiming to use ultrasound or vibration for meditation on Kickstarter or Amazon. Right, it needs precision without hitting safety limits. Consumer devices often lack this target. Yeah, so I'm wondering if we're ever going to be able to use this in a non-clinical sense, given how serious this is. Actually, like, you have to be really precise, or else you could just like modulate a different part of the brain that would, who knows what that would affect for you. Okay, let's learn some stuff. Okay, so then we learned about the phasic release of norepinephrine. This is something that's like just saying, hey, we got to get your attention right now. And it's basically the, the thing that jumps in the way of your attention and forces you, it scrambles what you were working on and forces you to focus on something else. And then we've got the tonic activity, which is more of like a baseline state in the moment. So depending on what you're doing and what task you're doing, for me right now, I'm guessing this is where we're at. Moderate, flexible mindset where the organism is responsive to relevant stimuli but not overwhelmed by background noise. Yep. And yeah, this is how it's directing, or this is how it's keeping your attention on things. Okay, the alpha 2A versus alpha 1 adrenergic switch in the prefrontal cortex. The impact of norepinephrine on high order cognition, specifically within the prefrontal cortex, is not linear. More norepinephrine does not always equal more focus. Instead, the relationship follows a distinct inverted U-shaped curve where performance is poor at both very low and very high levels of norepinephrine. The molecular basis, so we're talking to U with my mouse right now. We got low and low. Low performance. The molecule basis for this phenomenon lies in the differential affinity and function of adrenergic receptor subtypes. Okay, we don't need to know any of this stuff. This is too in the weeds. The focus pathway. All right, what's going on here? I would guess it's safer on a stable mind. That's also probably true. It's probably safer on someone who knows what they're looking for also and knows what's going on. Glute tomating. It's all about our glutes. It's all about the glutes. All right, the focus pathway, alpha 2A adrenergic receptors. It's the molecule gatekeeper of focused attention and working memory. These receptors are located postsynaptically on the dendritic spines of prefrontal cortex pyramidal neurons near the site of synaptic input. So this is what we were talking about yesterday, right? How it's where the receptors are. Is that, yeah, alpha 2, here we go. This is on the axon terminals, and this is the alpha 1. Alpha 1. Low affinity. Why would that be the case? This affects the trigger of the neuron. And then this was the one that affects the brake. And then what was this first one? Alpha 1 and beta. And this is signal amplification. Okay. So both of these things are affecting... both of these things are affecting the attention being there, and then this one's kind of fail-safe for too much going on, I'm guessing. All right, these receptors are located postsynaptically on the dendritic spines. So this is, yeah, the dendrites. Here we go. Near the site of synaptic input. Now, this is kind of odd because we're getting... This one was saying mostly alpha 1 and beta, but this one said alpha 2A. Because of their high affinity for norepinephrine, A2A receptors are activated by moderate baseline levels of norepinephrine release, the sweet spot of arousal. Okay. I don't think we need to know any of this stuff. This is too low level. Reduction that leads to the closure of that, blah, 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 blah. Yep, this is a functional consequence. Here we go. By closing these channels, alpha 2A activation essentially plugs the leaks in the neuron. This is what we talked about yesterday. This increases membrane resistance, ensuring that synaptic inputs from task-relevant sources are effectively transmitted to the soma to trigger action potentials. This strengthens the signal of the task at hand, enhancing working memory and the ability to resist distraction. What is this? alpha 2A agonists like guanfacine. What? This isn't real. Is a prescription medication. Nice. Primarily used to treat attention deficit hyperactivity disorder. Okay, so this is not just a prescription medication. I'm sure colloquially this is mostly used as a as a prescription medication, but this is actually something that's already in the brain, but we're just giving more of it, right? Come on. Is that what's happening here? Or is that what agonists mean? Oh, okay, never mind. That bind to specific cell activating. Okay, so maybe this is just the drug. Alpha 2A agonists like guanfacine utilize this mechanism to treat ADHD by artificially stimulating this focus pathway without inducing the agitation associated with psychostimulants. Ah, ha ha ha. Okay, what kind of meds use guanfacine? Is a non-stimulant. It is believed to work for ADHD by strengthening neural path networks and improving the function of the prefrontal cortex, the part of the brain that controls attention, working memory, and impulse control. Okay, I think my doctor actually talked about this to be paired with Vyvanse. Okay, the stress pathway, alpha 1 adrenergic receptors. This is the harbinger of cognitive disruption, right? We're talking these guys. Okay, but this says mostly alpha 2. What is happening here? I don't know. It doesn't matter which one's alpha 1, alpha 2. As long as we know that these mechanisms are in place. These receptors have a much lower affinity for norepinephrine, meaning they remain largely unoccupied during states of moderate arousal. They are only engaged when any levels rise dramatically, such as during acute stress or intense agitation. Mechanism of action. We just know the functional consequence. The opening of these channels hyperpolarizes the neuron. Do we see hyperpolarize? I don't know. And decreases its membrane resistance. This effectively shunts or suppresses the firing of the pyramidal pyramidal networks that sustain working memory. The result is a collapse of the hold function of the prefrontal cortex. The mind goes blank and impulse control evaporates. This is the neurobiological definition of choking under pressure or the fight or flight cognitive impairment. So this is what actually is used to get us to focus on something that we weren't focusing on that might be important for our safety. The transition from a state of high alert focused to stressed scattered is physically defined by the spillover of norepinephrine from the high affinity alpha 2A receptors to the low affinity alpha 1 receptors. Optimal cognitive performance requires maintaining norepinephrine levels within the precise window that saturates alpha 2A receptors without recruiting the alpha 1 pathway. Okay. Stan, would using creativity for meaning fit in the doc? Oh, what do we mean for meaning? So we definitely need creativity for the sake of our... Yeah, so effectively it's for meaning. We obviously need, not obviously, but we need creativity when we're trying to come up with, identifying what to pursue. We've got this making sense of the moment. And somewhere in here, we've got thinking, being precise, but we're like creativity needs to be somewhere here where we are talking, where like you don't need to be able to, but we can talk about how you can increase your ability to be creative to be creative about possibilities of your situation, of the world. Oh, like people say creativity gives them meaning. Oh, that, yeah, for sure. We have to do that in part 3 though. We can't do that anytime sooner. But yeah, we have to do like literally things, you know, things that can give you this feeling of meaning, you know, for your life. Like that, we would definitely want to go into creativity as a certainly as an outlet, or a way people do yeah, both as an outlet for expression, which can affect your self actualization, but then also just as a as a means for, I don't know, something enjoyable. Yeah, well, for sure. We're definitely gonna have to go into that for part 3. I imagine there's going to be a lot of stuff that we talk about in part 3 where we just go through a bunch of gold mines of positive emotion. Because that's really what we're looking for in part 3. We just want to feel like our life is meaningful. All right, the neuroadrenergic dopaminergic handshake, the LCVTA loop. While norepinephrine handles arousal and dopamine handles motivation, detailed in section 3. These two systems are functionally coupled at the source. The locus ceruleus sends direct excitatory projections to the ventral tegmental area, and the substantia nigra, the primary producers of dopamine. Okay, locus ceruleus. This was our norepinephrine guy, right? Yes. This is the one that's actually outputting the norepinephrine. As we said, it's got those, you know, it's releasing the norepinephrine along its axon, I think. Is that what we had here? Yes. En passant release. Passes through these beads. At each bead, norepinephrine is released en passant. We got to play some chess on this channel at some point. All right. Yeah, true. This is definitely made up. What's all this then? What are we referring to? Which part's made up? Fake news. My uncle said it was different. I'm not sure what we're referring to now, but okay. So the locus ceruleus sends direct excitatory projections to the ventral tegmental area, the primary producers of dopamine. So norepinephrine is affecting dopamine. That's the Fortnite. Oh no, what's the Fortnite way of saying this? When you shoot is there like a plant, something like some bubble plant or something? When you shoot it, it like explodes. That's the Fortnite way of saying it. The norepinephrine is the shot you're shooting, and then it's affecting the release of dopamine. All right, what is a locus ceruleus? A Roman in general? Come on. True. Yeah, I don't know where these things come up with their names. I don't know what they mean. It's just kind of a name that you just have to, I don't know. You don't even need it. These names aren't important. It's just there's a part of the brain, a network of neurons that release chemicals along their axon, which is just their branch, I think. Is the axon usually described as the branch or root? Okay, it's the branch. So this is after the neuron. Post nucleus, it branches out. But pre-nucleus, you've got these like roots that are taking in signals, and then you've got these longer branches outwards. Ventral tegmental area sounds like an auto-generated or terrible answer you'd hear on Jackpot when the host asks you to come up with words for what VTA stands for. True, true. I'm a huge hater of that game, mainly because I just don't enjoy it. Like, I'm not good at it, but it's actually very fun to watch. I'm so terrible at coming up with funny things in the like that in the moment. Like, I think I could come up with funny things, like, if you give me, like, I don't know, 10 minutes. But yeah, Quiplash, I'm just terrible at Quiplash. Any of these, like, really fast thing. I'm terrible at trivia, terrible at Quiplash, terrible at I don't know. Old people like Latin. That's how the world works. True, until they croak, and then the next old people are gonna like, I don't know. Okay. This connection provides the mechanism explanation for why physical arousal often precedes mental motivation. A wake-up signal generated in the LC, for example, by exposure to cold water, intense breathing, or physical movement, triggers a phasic burst of norepinephrine. This norepinephrine release stimulates the VTA, prompting the release of dopamine into the nucleus accumbens and prefrontal cortex. The implication for friction. This supports the concept that friction, the sensation of agitation or strain at the beginning of a task, is largely a neuroadrenergic event. This friction is not a signal to stop. It is the necessary physiological trigger that jump-starts the dopaminergic engine. The accumulation of norepinephrine is the spark that ignites the fuel of dopamine. Okay. Co-release. Furthermore, recent evidence suggests that LC neurons can co-release both norepinephrine and dopamine in the hippocampus and cortex. This indicates that alertness and encoding are often... Ooh, encoding. I haven't heard the dopamine as encoding, but we're getting to that. Alertness and encoding are often chemically packed together to ensure that salient events are not only noticed but also learned. This makes sense because, like, you know, let's imagine that the thing I was talking about yesterday, where my neighbor somehow breaks the floor and it falls down in my room. Not only is the norepinephrine going to literally disrupt my focus right now, like it's making it so that the global network is effectively scrambled, so that whatever comes next needs to be, it needs to be different in some sense. But then it also needs to affect my motivation to figure out what the hell just happened, and that's where the dopamine comes in. So norepinephrine causes this fight or flight, but then dopamine starts coming in, and I get this huge rush where I'm motivated. We're sparking up. Esches? We're sparking up. Is that like we're getting joints or something? Someone call Mark Zuckerberg because I need this global network up, baby. Get in touch with the microglias and let's start glutamating. Absolutely. Hey, we've got these. Each of us have these networks in our head. There's a bunch of glutamates up there. There's a bunch of, I don't know if that's really a terrible way to say that. We got a bunch of microglia. They said spark up somewhere in there. Oh, spark up. Spark. Jumpstart. Spark. That ignites the fuel. All right. The spotlight of attention, acetylcholine, and top-down control. All right, so we're jumping the gun. We're going to a different molecule. This is another one that Andrew Huberman talks about all the time. If norepinephrine is the volume knob of the brain, the multiplier, increasing the overall intensity of processing, acetylcholine is the spotlight, directing that intensity toward specific sensory inputs or internal representations. The cholinergic system is the primary mediator of selective attention and top-down control. So how does this work? How does it work? Let's go. Anatomy of cholinergic projections. The brain's cholinergic innervation, that is the supply of nerves to a body part controlling its function. Is this, what's the antonym of this? Is it like enervate? Is from the body to the brain? To the nerves? Okay, the brain's cholinergic innervation originates primarily from two major hubs. The basal forebrain complex, specifically the nucleus basalis of Maynard. This is the first time I've seen Maynard. These neurons, do you think this is just a scientist's name? These neurons project extensively to the neocortex and are crucial for arousal, plasticity, and sustained attention. Why? The pontine nuclei, including the latero-dorsal tegmental and pedunculopontine tegmental nuclei, which project to the thalamus and midbrain dopamine centers, regulating the transition between sleep and wakefulness and modulating reward circuitry. Okay, we gotta figure out what's going on here. All right, mechanism of signal-to-noise enhancement. The defining function of acetylcholine in the cortex is the enhancement of the signal-to-noise ratio. It achieves this by modulating the responsiveness of cortical columns to sensory input. Okay, we need to ask some questions here. If Ne and ACHC, ACH are both affecting signal-to-noise ratio, how is their mechanism different? Which let's just ask that, actually. It achieves this by modulating the responsiveness of cortical columns to sensory input. ACH acting on nicotinic acetylcholine receptors, particularly those containing the beta-2 subunit, enhances the release of glutamate. Glutamate enhances the release of glutamate from thalamocortical terminals. This amplifies the signal, the transmission of sensory input information from the outside world via the thalamus to the cortex. All right. While they both improve the signal-to-noise ratio, they do so by solving two completely different problems. The simplest distinction is global contrast versus local focus. So global contrast is norepinephrine. Wake up and pay attention to something. It doesn't care what it is. It's gonna amplify whatever you do, whatever you pay attention to. But acetylcholine is focused specifically on this detail, local precision, which means that the release, like where acetylcholine is released, is really important. And I'm guessing that's because of what we said. So this is what? This is originating, but where are we releasing? Okay, norepinephrine. Yep. Distribution, diffuse, but topographic. It can target a specific region, for example, just the visual cortex, without activating others. So the feel, alertness, is from norepinephrine, but this one is concentration, the feeling of scrutinizing a detail. So acetylcholine is what allows us, despite our alertness, so you're quite alert and you're looking around and you see that something is wrong, right? You know, maybe someone, you walk into your room and someone puts something on your bed, but you live alone. And so you're looking at that thing. The thing that's keeping that visual information in your brain, I believe, is this acetylcholine here. It's making it so that those regions are, yeah, what would this be? Are effectively dominating the global workspace. It's basically I'm guessing it's basically causing ignition after ignition. So does ACH effectively influence ignition local ignitions such what's a word that means like over and over again? Currently? No. Not just periodically. Rapidly and progressively, but continuously? Continually. Influence local ignitions rapidly and continually such that that local region dominates the global workspace. Regions signals dominate the global workspace and consciousness. For example, when you focus on a cup sitting on your desk. All right, maybe I jumped the gun though. We gotta read more of this stuff. How they changed the math. You recall that NE improves signal noise ratio by acting as a contrast agent. ACH improves SNR by acting as a filter for reality. So ACH boosting bottom up, suppressing top down. This is the most critical mechanical difference. The brain is constantly balancing what I see, sensory input, versus what I expect to see, internal prediction. The acetylcholine boosts the input. It amplifies the signal coming from your eyes/ears into the main input layer of the cortex. It makes the raw data louder. Okay, that's cool. ACH suppresses the internal talk. It simultaneously dampens the feedback connections from other parts of the brain. It stops you from daydreaming or hallucinating patterns that aren't there. So the next question is, does mindfulness meditation training effectively increase one's ability to deliberately maintain focus? In other words, release ACH. Okay, the result, ACH forces your brain to trust the data over its prediction. So I think I'm now wrong about what I asked first. It might just be a whatever is going to be winning separate from this mechanism. It'll highlight the bottom up signals. All right, the metaphor, the dark room. Imagine you are in a dark museum trying to look at a painting. Norepinephrine is the floodlight, contrast. It turns on the overhead lights and creates harsh shadows. Okay, but acetylcholine is the flashlight, precision. You point a beam at one specific painting. Okay, how they work together, the orienting response. In real life, they almost always work in a sequence known as the circuit breaker model. The interrupt is norepinephrine. You hear a loud crack. The locus ceruleus fires a phasic burst. The whole brain wakes up. Global contrast increases. The shift, ACH, your brain realizes the sound came from the window. The nucleus basalis releases acetylcholine specifically to the auditory and visual cortex. So maybe I was right. Maybe it is actually maybe it does favor certain regions, but maybe it's just certain regions. Like maybe it wouldn't ever favor top-down signaling. You stare at the window. NE keeps you alert, but ACH ensures you are processing the visual details of the cracked glass accurately, rather than just panicking or imagining things. All right, yes, you have hit on the precise mechanism of selective attention within the global neuronal workspace theory. You're describing the concept of biased competition. Global workspace is a winner-take-all system. Only one major thought can dominate consciousness at a time. Acetylcholine is the mechanism that rigs the vote so that the local region processing the cup wins the election against everything else. The sound of the AC, the feeling of your chair, etc. Here is how ACH influences those local ignitions to ensure global dominance. So I have to ask, does ACH only get used to rig the vote in favor of bottom-up signals, or does it ever allow focus on top-down thoughts? For example, ensuring that our DMN is making its way into the global workspace. Okay. The goal, escaping the local circuit. Normally, sensory signals like seeing a cup die out quickly. They stay in the visual cortex and fade away, subconscious processing. To reach consciousness, a signal must generate a local ignition, a self-sustaining burst of activity strong enough to broadcast to the parietal and frontal lobes. How ACH fuels the ignition. Acetylcholine targets the specific cortical column, analyzing the cup, and modifies its firing in two distinct ways, matching your rapidly and continually description. Rapidly, nicotinic receptors. This is this one, right? No? Didn't we just see these words? No, I don't remember. They're fast when acetylcholine hits them on the presynaptic terminals of the thalamic inputs, the raw visual data. It creates a massive immediate boost in glutamate release. Okay. Okay. So it's affecting the excitatory signals of bottom-up data. It makes the initial visual signal of the cup loud enough to shock the local circuit into action immediately. All right, continually. This is the key to consciousness. Muscarinic receptors are slow. They close potassium channels, which prevent the neuron from resetting to rest. The neurons processing the cup enter a state of sustained depolarization. Instead of firing once and stopping, they keep firing. This creates a reverberating loop or attractor state. There we go. The image of the cup is now held in the visual cortex even milliseconds after the photons have hit the retina. All right, okay. Dominating the global workspace. LOL, damn. Now that acetylcholine has helped the cup circuit achieve a sustained high-energy state, ignition, the winner-take-all dynamic takes over. Long-range broadcasting. Because the cup neurons are firing rapidly and continually, thanks to acetylcholine, they successfully send spikes down long axons to the prefrontal cortex. This is the critical part. As the cup signal grows stronger in the workspace, it activates inhibitory neurons that suppress other competing signals. Aha. Lateral inhibition. We're going to probably get to this. This is it. Noise suppression. Simultaneously, acetylcholine acting on muscarinic receptors. That's what this said, right? Muscarinic receptors are slow. They close potassium. Yep. or they're slower. They close potassium channels. All right. Can suppress the lateral spread of excitation between intracortical connections. This effectively dampens the noise of background chatter of intrinsic cortical activity. A brain state characterized by noise-free, high-frequency signal detection. Oh, that's the result. In the visual cortex, this manifests as a sharpening tuning curve where neurons respond vigorously to their preferred stimulus orientation but are silent to non-preferred stimuli. So the result, the cup becomes the only thing you're aware of. Summary, the rigged election metaphor. What happens if acetylcholine fails? If you block acetylcholine with drugs like scopolamine, this mechanism breaks. The cup signal enters the brain, but it cannot sustain the reverberation. It never reaches the threshold for ignition. You might physically see the cup, your eyes track it, but you are not conscious of it. You become delirious, unable to hold a thought or focus on an object. The workspace becomes unstable because nothing can win the vote. Yikes. All right, we can finish up after we do this thing. We can talk about the interaction with norepinephrine tomorrow. But we're slowly getting this. We're slowly understanding. All right, this is a great question because it touches on the subtle difference between wandering, DMN, and working memory, holding a thought. The short answer is no. Acetylcholine generally suppresses the default mode network. It is arguably the chemical enemy of the default mode network. When you deliberately focus on a thought, like solving a math problem or holding an image in your mind, you are not using the DMN. You are using your central executive network. Acetylcholine is absolutely required for this, but it works by locking that thought in place and blocking the daydreaming signals of the DMN. Aha. Okay, here is the breakdown of how acetylcholine handles internal versus external focus and how meditation fits in. The top-down paradox. In neuroscience, top-down can mean two different things, and acetylcholine treats them differently. So I think this is the same type of thing. I'm guessing. I'm going to intuit that this is similar to what I'm trying to get at with top-down processing. Like when we're talking about this idea that I have in my head that I'm deliberately putting my attention on something, it's not actually just top-down signals that I'm leveraging for that experience. That is a top-down and bottom-up conjunction of signals that's giving me this linguistic understanding of what I'm trying to do, and that's affecting top-down signals, but also bottom-up signals. But then there's just top-down signals, which are you know, when thinking about the brain, you could just think of it, they're the predictive signals, and you know, they're constantly clashing with the bottom-up signals. So it would be the case where it would actually stunt. I'm guessing it's going to stunt top-down signals. It's not going to actually, it's not going to help out those top-down signals. However, it can help out our focus, obviously. Like when I think that I'm going to focus on this cup, it seems like it's helping me out. So you might think it's helping out top-down signals, but really, it's helping out this bottom-up interaction of what I'm actually noticing in terms of bottom-up. Like my when I'm doing this, my prediction is, I mean, I guess I could keep asserting a prediction. So you know what? Maybe that's off. We'll see. Let's figure it out. All right, the top-down paradox. Top-down is prediction/daydreaming. The acetylcholine suppresses this. Normally, your brain is a prediction machine. It projects old memories onto the world, so it doesn't have to work hard to see. This is largely driven by feedback loops from the DMN and hippocampus. Acetylcholine action. It severs these feedback connections. All right, so this is in line with what I was saying, I think. Why? It forces the brain to shut up and listen to the raw data. Bottom up. If you have high acetylcholine, you stop hallucinating/predicting and start perceiving reality accurately. All right, top down is executive hold. ACH boosts this. This addresses your specific example of focusing on a cup or holding a thought. This is working memory centered in the prefrontal cortex. Acetylcholine excites neurons that hold the rule or goal. It creates a privileged state for that specific circuit, protecting it from interference. To hold that thought, acetylcholine actively suppresses the DMN. It stops the mind from wandering so the local ignition of your focused thought can survive. So I think this goes hand in hand and full circle with what I said earlier this stream, where the synchrony that we see from a trained meditator would actually involve less predictive authority, in the sense that you're not going to jump to some alternate conclusion or some forward-looking expectation. You know, it's being fine in the moment. Everyone's on the same page and we're good. We're chilling. We don't need to be constantly interrupted by what is next. Okay. I just glutamated my first meal ever in my new air fryer. Pretty cool machines. Are we gonna just start? We start using this as a verb, but it never means the same thing. We could use it for anything, provided it's inferable what we're trying to say. That's the rule. I'll say. Welcome back, Daniel End, and I'm glad to hear that the first air fryer meal was a success. I'll give you a Sherma. What's the bigger one? What do I have that's bigger? I'll give you a ShermaDink. All right. To hold the thought, ACH actively suppresses the DMN and stops the mind from wandering so the local ignition of your focused thought can survive. Acetylcholine doesn't... Yo, what is that? Peepo happy? Nice. See, I just want ShermaDink to jump around my screen. I'm guessing that some of these are... Is it going to be the case where only better Twitch TV emotes can jump around, or is there something else going on? Maybe I can set that up in Streamlabs. I'm not sure. All right, does mindfulness training increase acetylcholine control? Yes, current research strongly suggests that mindfulness training strengthens the neural pathways that trigger acetylcholine release. You can think of mindfulness not as relaxing, but as weightlifting for the nucleus basalis, the source of acetylcholine, the attention circuit training. When you practice mindfulness, you are cycling through a specific loop. Focus on your breath, high acetylcholine, sustained attention. Mind wanderers, acetylcholine drops, DMN takes over. Notice the wandering, salience network, anterior cingulate cortex fires. Shift back, the anterior cingulate signals the nucleus basalis to squirt acetylcholine. When do we get to squirt? Why did you describe ACH release as squirt? All right, because yeah, the other one that we talked about yesterday, norepinephrine, is a leak. It's like it's leaking. But this one is going to be more of a squirt, I guess. All right. The long-term result. Long-term meditators show structural changes in the anterior cingulate cortex. The ACC is the bridge between your willpower and the chemical release of ACH. A trained meditator doesn't necessarily have more ACH floating around constantly, which would cause anxiety. Rather, they have a hair trigger response. As soon as they intend to focus, their brain can flood the specific cortical area with acetylcholine instantly and precisely. Now, this is the type of functional level that I would like to entertain, perhaps in the document, like that you have the ability to Literally, you have more control over the part of your over the part of your brain that releases this neuromodulator that affects your focus. You asked about deliberately maintaining focus. Advanced mindfulness, open monitoring is a unique state. You are not focusing on a cup, but you aren't wandering either. You are watching the DMN without getting sucked into it. Nice. This is a high energy state where acetylcholine is likely high in the salience network, keeping you alert to internal events, thoughts, as if they were external objects. Ah, so this is where you're taking in the linguistic thoughts that you might be having as bottom-up data. You're paying attention to those bottom-up signals. You're effectively treating your own thoughts as oh my gosh, I'm right on the money. As bottom-up sensory data to be observed rather than top-down realities to be believed. Okay. If you're interested in weightlifting aspects of this, would you like a breakdown of how open monitoring versus focused attention meditation techniques rely on different ratios? Yes, I do. Yes to your question. And also, why did you describe ACH release as squirt? Okay. Which air fryer? Me glutamating with my anterior cingulate cortex on the low key. I mean, that's everyone, right? Is it so? Glutamate, I think we described is literally just the excitatory molecule. So this is the molecule that, like, this is what people usually think about when they think about brain activity. Like, you're always just exciting the next part of the brain. But there's actually the other, there's other molecules that inhibit. So imagine that, some brain connections are literally just there to inhibit the following neurons. Okay. So we're actually all glutamating with our anterior cingulate cortexes on the high key too, and such that, like, I think they are like literally the mechanism that makes something high key. Oh, I think it might be region locked to Scandinavia. It's actually it's called Onyx cookware. Not sure though. 2x4 liter compartments. Hell yeah. Sounds like Gemini might need a good stern glutamation with all this squirting. I don't even know where we're going with that one. All right, here's the breakdown of neurochemistry behind the two major meditation styles, followed by an explanation of the specific word choice. I just want to know the specific word choice right now. We can talk about the other stuff tomorrow. I use the word squirt intentionally, though I admit it sounds unscientific! Exclamation point. In neuroscience, this colloquialism is often used to correct a common misconception about how these chemicals move. When people hear release, they often imagine a slow, misty diffusion, like perfume wafting across a room, but the release of neuromodulators is often phasic, pressurized, and directional. The vesicle mechanism. Neurotransmitters are stored in tiny bubbles, vesicles, under pressure. When the neuron fires, these bubbles fuse with the wall and eject their contents violently into the gap. It is a physical ejection event. Especially with the nucleus basalis, the axons don't just leak. So it seemed like with norepinephrine, the release is diffuse enough that it like directionality doesn't really matter. That's the sense I got. So we could think of them as leaking, pressurized leaking, you could say. But here, the axons don't just leak; they target specific columns of the cortex. Squirt captures the idea that the brain is aiming a hose at a specific spot, the visual cortex only, rather than just raising the humidity of the whole brain. It happens in milliseconds. Flow implies a stream. Squirt implies a pulse. The distinction matters because the pulse is what allows you to snap your attention to a distraction instantly. Okay. What's the next question here? Nah, I don't want to ask that. All right. I think we're gonna call it there. What do we got here? We got. I don't even know who that guy is. Wait, no. Oh, we got wine time. Nope, we got tea time. Absolutely. Absolutely. Alrighty. 2 hours, 9 minutes. Hell yeah. All right, more learning coming tomorrow. What do we have set up for tomorrow? Oh, that's my personal one. We got, oh, that's also my personal. There we go. It's gonna be hard for me not to dox myself if this channel ever gets big. All right, we've got topic to be determined. Maybe we just continue on this. I'm not sure. What do we do? What do we do? Do we just start looking into mindfulness techniques? Because mindfulness is like even though mindfulness has this idea or this connotation that it's like some type of meditation, some side thing, like mindfulness is really the extreme of a skill that is involved in all of our attention at all time, right? Like when we're trying to focus on our schoolwork or our job, right? Like we are dealing with mindfulness skills, and that skill of focus is something that you can grow, like you can strengthen that skill, and so that's why it's so important. All right, what do we got here? Part of a series of Pepe.
To the end of another
Oh
year.
no, oh no. Is a poorly drawn variation of Pepe created in the style of Sparta, while originally popularized in the Finnish image board is this would it be pronounced Lilauta? Yalta? I don't know. The character is also frequently posted on 4chan where he's referred to as Helper. Nice. What's going on with the eye? Like the part under his eye? Or is his eye just bulging out? Okay. Oh, there we go. We got pet parrot, and then we got rare parrot. Did you have to do? Oh no. How do you get them both together? Oh, you do the thing first, and then you do pet. Like, can I do? Is that something that you can do? Yo, Energy Daunter, what's good? Just type one after the other, but I have to type pet second. What is it? Is it all caps? Pet? Is that how this works? Are these all case sets sensitive? Yo, there it is. Okay. We have to check. Is this case sensitive? Yes. Absolutely. All right. Scientific method in the flesh. Oh, what is this? Steer R? We got it. Pepe, please. Okay, this is getting a little wild. So what's determining which ones can show up on my screen and which ones aren't? Because we're not getting all of them, right? Pet's not showing up on the screen. But our pot friend is. Pot friend's showing up on the screen. I have no clue. Oh, there's Christmas emotes. Oh my gosh, I love Christmas emotes. How do I get Christmas emotes? Is it just Christmas tree? Or is that that's actually probably one of the normal emotes. Okay. People like to change out their emote sets when it's Christmas or a holiday season. I see. I mean, on the screen, the ones are Christmas themed. Oh, is that? I see. That when you put a normal emote, it's giving like a Christmas version on the screen, or did I misread that? Oh, look at that. Just absolutely perfect. All right, what is this? Fortnite? No, this is I was gonna say Team Fortress. What do we got? What do we got? Streaming tools, overlays, scuffed overlay, emotes, settings, enable seasonal hats. What does that mean? What are seasonal hats? Chat emotes on, show all, combo mode, random, subscriber only, enable emoji, yes. Custom emotes. These custom emotes are used to allow triggering images of your choice from chat messages based on words or phrases you choose in addition to normal chat emote behavior. If multiple of these match the same message, then you'll get multiple. Oh, can we hide this thing? It just showed up there. Oh, we can move that. So on subscribe, no, we want custom emotes, right? Okay, so I have to literally add an image. There it is. Use regex. Okay, unlimited emotes per user, emote duration on screen. Emote, emotes explosion. Animation random show 400 emotes whenever we've got subscribers, raids. We should do followers, right? Actually, no, we can't do that much craziness for a follower. I think it's more fun when something crazy happens. All right, what's going on here? We've got Potmas, authenticate extension to manage emotes. What does that mean? Okay. Sign in. Oh, it's not letting me sign in. That's lame. I think that's because it thinks it thinks it's a pop-up. Oh man. Testing 1 2 3. Hebbian theory. Do you believe that is relevant for the document out of curiosity? Did we not see Hebbian like mentioned today? Is a neuropsychological theory claiming that an increase in synaptic efficacy arises from a presynaptic cell's repeated and persistent stimulation of a postsynaptic cell. It is an attempt to explain synaptic plasticity, the adaptation of neurons during the learning process. Hebbian theory was introduced, blah, blah, blah. Let us assume that the persistence of repetition of a reverberatory activity tends to induce lasting cellular changes that adds to its stability. When an axon of cell A is near enough to excite a cell B and repeatedly or persistently takes part in firing, some growth process or metabolic change takes place in one or both cell sites that A's efficiency as one of the cells firing B is increased. Yeah, this is just neurons that fire together, wire together. Yeah, we believe this. This is good. This is, I think, pretty agreed upon. Is it relevant? I think we already talked about it in the topic of neuroplasticity. Yeah. Okay. What is causing... Enable emoji. I don't know. I'll have to work on that later. All right, let us call it here. More fun to be had tomorrow. Oh, we gotta. Well, I need to try this emote explosion thing. Yo, I don't. Is that really what causes it? I think it's the emote explosion only happens when someone subscribes, which they can't do right now, or if someone raids us. So I don't know if you recall when we've been raided in the past, but that causes the emote explosion, and it's like a lot of emotes, if I recall. Like it creates like a ton. Can I simulate one actually? You know what? Let's go back. Let's have some fun here. Let's go. Oh, where do I do this? I don't think I would just do it here. Actually, maybe I do just do it here, and I emulate a subscribe event. 1 subscribe. There it is. That's the emote explosion that we're talking about. Oh, it just keeps going. Man, that is a lot. Can I not choose which show up in the explosion? Animation random. Show 400 emotes. That's what I have. We can go bigger. We could go 1,000, but maybe 400's good. 412. Emotes for explode. Yes, yes. This is what we want. All right, can we find? Oh, but this is gonna be Twitch emotes, right? And they got rid of the pot. Oh, this is selecting and not selecting. So. Oh, geez, I can't make any sense of what's going on here. Yeah, we're gonna need some channel emotes, and we're gonna have to leverage those. But we could just do parrot, rare parrot. I don't know if I want a bunch of Pepes, honestly. I don't know who these people even are. Like, what is happening here? Yeah, I'm probably just gonna get rid of these random faces. Let's not. All right, I could do this later. Oh, we could keep the dog. Twitch raid. Yo, the frog. Yo, we got a sloth. Cheetos good. Sugar, nah. Yay, no nay. What's even going on? Copy this? No, come on. Pasta that? Nah. Give, please, take. All right. Kapow's pretty funny. What do we got? What do we got? Oh, we got to keep the dog. I don't know what that means. The fish. Okay, that's fine. Tomb raid. I don't know what's going on with these. Oh, yeah. Squid 4. Squid. Why is there a bunch of squids? Football, nah. Blocking, nah. Challenge, nah. Oh, yeah, we gotta get Santa in there. Bop. Alright, I'm gonna submit that one. Okay. They're really old Twitch emotes, probably staff or something. And now let's do a raid event of 50. Whoa. Why do I feel like there's a bunch of faces here? What's happening here? What just went? Oh my gosh. Did anything that I just do oh no, I have to save. I have to save. That's why, right? I have to save this and now subscribe event. I see a face, but I see many few. No, I see a lot of faces actually. Did I miss a lot, or is this just not taking into account what I'm doing? Oh, look at that. They're all the same. Well, I just wasted time. All right. I gotta leave on that one. Nothing more fun than wasting time. All right. Thank you everyone for chilling. We will continue tomorrow. Continue the grind, the winter grind. Yeah, have a good rest of the day. See you later.